to break this up a little bit and put the quadrilateral stuff separate from just the distance formula, midpoint, and parallel and perpendicular lines. But most of our types of problems that we have include, most quadrilaterals include parallel and perpendicular lines. So, at the top of your page, we're going to write down the slope formula. And we're going to write down the distance formula. Paper's bubbled here. Y2 minus y1. Okay. So the reason I'm putting those down is because if, like in a parallelogram, opposite sides are parallel, if we can find the slope of those lines, we will know are they parallel or not. On a rectangle, if these two slopes come out perpendicular, we know that that could be a rectangle because the lines are perpendicular. Or maybe it's a square. So how could I tell the difference? Well, if side AB and side AD are different sizes, then maybe it's a rectangle, whereas maybe if they're the same size, then it could be a square. So there's all kinds of situations here. Let's write down some of the characteristics you remember. I've labeled a lot of things in the pictures to kind of help with this. So for instance, maybe you remember those arrows mean opposite sides are parallel. We also know opposite sides are congruent. One of the things that we have in the picture, opposite angles are congruent. We have diagonals bisect each other. Let's see, those are those marks, those marks, those marks, those marks. Okay, so the couple that I want you to focus on today that will be helpful in determining if the ordered pairs I give you are these is I really want you to focus on the top two things. Opposite sides are parallel and opposite sides are congruent. Because everything I'm going to give you doesn't really relate. I'm not giving you any angles, okay, so we can't do that. I'm just giving you points. And based on those points, we're going to find their slope and we're going to find how long they are. And that will tell us, are they parallel or are the sides congruent? Those are two main things we need to focus on for parallelograms. Rectangles, we still have opposite sides are parallel. We have opposite sides are congruent. We have 4 right angles was on our little, what do you call it, flashcards we may have made. So if you have right angles, that means that lines are going to be perpendicular. And that's important to know that 90-degree corners make perpendicular lines based on what we learned today. We could also say diagonals are congruent. And bisect each other. I think that's pretty much everything labeled in the picture. So key things to know about a rectangle. Opposite sides are parallel, so you're going to look at slope for that. Opposite sides are congruent, you're going to look at their distance formula. And then this one. If their slopes are perpendicular and opposite sides are congruent, then you're going to know that it's going to be a rectangle. Alright. a rhombus. We have opposite sides are parallel. We have 4 congruent sides. Diagonals are perpendicular. We have opposite angles are congruent. And bisect. The angle. Diagonals are not only perpendicular, but they do and bisect. Each other. And then ran out of room. So, congruent sides, perpendicular diagonals, opposite angles. So, on this for today, to figure out given ordered pairs, if opposite sides are parallel, then if we have 4 congruent sides. Okay, so these are 2 factors that you want to look for with a rhombus. You're going to see that they're parallel, but instead of opposite sides being congruent, all 4 sides would be congruent. The last one we have is a square. We need opposite sides parallel. We need 4 congruent sides, and we need 4 right angles. And remember, 4 right angles means we have perpendicular lines. Now I could keep listing diagonals are congruent, diagonals bisect, diagonals are perpendicular. You can see all those 90-degree corners are broken to 45. And like I said, I could list them all, but for today, the main thing we want to look for is this one has 4 congruent sides and perpendicular lines. Okay, we can say that opposite sides are parallel, but I don't necessarily have to find that one, and I'm not going to list out all the properties. I'm only going to list out the ones we really want to focus on how to prove given some ordered pairs. Okay, so slope or the length questions. Draw a picture. We have a quadrilateral with J is located at that point, K is located at that point. So I don't know what the quadrilateral is. You can draw it as a rectangle, a parallelogram, anything. It says, what is the slope of LK in order for this to be a square? Okay, well let's draw it as a square then. When you draw these pictures, J, K, L, M, you pick a corner to start at, and you need to go around the outside of that corner, outside of the box. So we have J, and we have K. So we have this side here. What does the slope of LK have to be for this to be a square? So in order for this to be a square, this would need to be 90 degrees. So let's find the slope of JK. So we're going to do y is on top, so 2 minus 5, x is on bottom, 2 minus negative 2. In order for KL to be a square, this has to be perpendicular. So the perpendicular slope would be positive 4 over 3. So you find the slope. In this case, when I drew the picture, JK has to be perpendicular to KL in order for JKLM to be a square. So I found the slope of the first one, and to be perpendicular, you do opposite reciprocals. So that would be an opposite reciprocal. So that has to be LK, the slope of LK. Alright, we're going to draw this picture. This one says, what if it's a parallelogram? So let's draw a parallelogram. We'll put some letters A, B, C, D. We are given A and B, so I'm going to put a little star here. What is the slope of CD? So what does this slope have to do in order to make this a parallelogram? So what do you know about these two lines? Well, those two lines have to be parallel. So we'll find the slope of AB. Y is go on top, 8 minus 6 over x is on bottom. 2 divided by negative 1, we'll say is negative 2. So the line CD is parallel to that, so I'll say CD's slope would equal negative 2. Because they have to be the same, because parallel means the same. Alright, look at the next one. Now it wants us to identify what kind of quadrilateral it is based on this information. I'm going to tell you based on it has to be a parallelogram, rectangle, rhombus, or square. We're going to assume that opposite sides are parallel. So we're not going to even show that information. When I'm going to draw this, let's draw a picture over here. Whatever kind of shape, I don't know what kind of shape. You can draw a parallelogram, just so you know, RSTU. Okay, so based on that information, you want to find two sides next to each other. So let's say I do RS, and I'm going to choose, highlighter, to do ST. When I say do these, I want to find the slope of these two sides, because if the slope comes out perpendicular, I know that automatically makes it a rectangle or square. If these slopes don't come out perpendicular, then it's going to be a parallelogram or a rhombus. So that's going to help eliminate two choices just by finding slope. So we're going to start with the slope formula. And we're going to look at RS. So you always want to do two sides next to each other, because if I did opposite sides, those are all going to be parallel on these. So RS would be 2 minus 3 over 5 minus 1. That's negative 1 over 4. So I said that was RS. And then let's do ST. Negative 2 minus 2 over 4 minus 5. Negative 4 over negative 1 equals positive 4. So these are definitely perpendicular. They are considered opposite reciprocal. So I'm going to put a little perpendicular symbol here because they are opposite reciprocal. So that means my choices now for perpendicular are going to be rectangle or square. So how I know the difference in that is to know how long the sides are. If RS is the same length as ST, it's going to be a square. If RS is not the same length as ST, then they're different. That makes it a rectangle. So you use the distance formula. So let's say I find the length of RS. So x's go first, so we'll do 5 minus 1 squared plus 2 minus 3 squared. We get square root of 17 for RS, and we'll do ST. X's, so 4 minus 5 squared. Y's are negative 2 minus 2 squared. Negative 1 squared plus negative 4 squared. 1 plus 16 equals square root of 17. Same. Since they have the same length on their sides, that means that all four sides are going to be the same. So if all four sides are the same, I would say the answer to this one would be a square. So Our slope determines if they are perpendicular, then we know it's going to be a rectangle or square. Then if all the sides come out to the same, which again, if you just do two consecutive ones, we'll know. If they're the same, then it's got to be something with the same length sides. Maybe pause the video, try the next one on your own. So I'm going to use the sides of AB for this one. A little big with my coloring there, and BC. So we're going to start with slopes. Slope of AB, you subtract y's on top over x's. And I find the slope of BC, y's on top over x's. Well, those clearly are not the opposite reciprocals. They are definitely not. So if it is not perpendicular, so if they are not perpendicular, our choices are a parallelogram, or a rhombus. Now to tell the difference, in a rhombus, all the sides are the same. In a parallelogram, they're not. So now we use our distance formula to figure out how long those sides are. So x's, we do 1 minus -2, which we can make that plus. 4 minus 3. So we get 3 squared plus 1 squared is 9 plus 1 equals square root of 10. And you don't have to simplify. We just have to see if they come out looking the same. BC, distance formula. 1 minus 1 squared plus 2 minus 4 squared. -2 squared. 0 plus 4 equals square root of 4. Those are definitely not the same. So, not the same means I would say if they're not the same, they have to be the same to be the rhombus. If they're not the same, we'll say this one is a parallelogram. So key choices. Find slope first. If they are perpendicular, we have rectangle or square. If they're not perpendicular, it's a parallelogram or a rhombus. So then you look at how long the sides are. If they come out the same, you know it's probably going to be the one with all the same sides. If they are different, that means that the sides are not the same. Okay, last one. On the test and stuff, we'll give these graphs for you. I didn't graph these yet though. So 2, 1. I'm going to highlight this axis. It's a little hard for me to see. Okay, so the point 2, 1 is here. 4, 0. 6, 4. And this is our rectangle. And we have to estimate where we think this point's going to be to make this, finish the rectangle. So I know it's in this general area up here. So it has to relate to slopes. So let's see. To get from this point to this point, it has a slope of -1 over 2. Okay. If you look at the slope KL, I went up 4 over 2 to get there. So I could do that same approach if I go up 4 over 2. That should be my mystery point. Let's see if that works. So this point here would be 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4, 5 would be where that would be located. If you want to check it, you could check to make sure this slope, down 1 over 2, matches this slope. So you have opposite sides are parallel, or perpendicular for this one. Parallelogram, let's start by graphing our points. Again, I'm highlighting this because I can't see it very well. We have the point -5, -1, -4, 2. So that's A, we have B, we have C at -3, 0. Okay, and we're looking for D. Remember, they have to go in order though. So if this is A, B, C, I know that my point has to be down here somewhere because you got to follow the pattern. So I don't think I grabbed something right there. Or it's not a rhombus. Could have been my mistake on graphing that. Let's see. I graphed the point -5, 1, 2, 3, 4, 5, -1. -4, 1, 2, 3, 4, up 2. I think that one point just is in the wrong place. Oh, it's a parallelogram. That's okay. That's supposed to be the same on all sides. Parallelogram is not the same. So we're doing a rhombus there. Okay, so the slope from A to B would be up 1, 2, 3 over 1. So I need to find the point that matches that. Or you could do BC. 1, 2 over 1. So if I went down from A, 1, 2 over 1, that would be my missing point D. So D has the ordered pair of 4, -4, -3. Hopefully. And I think it says justify, so I might just say like BC had a slope of down 2 over 1, so I found AD by going down 2 over 1.